For this video, we're going to continue working on both crouching and proning. We'll also be creating a custom editor to change how we can interact with the state machine behavior event script. If you haven't done so already, please check out the previous part of this series. We go through how we implemented the crouch and proning functionality to our character controller, and we'll continue from where we left off. If you have seen the video, you'll know that we're going to fix the transition between our states, and we're going to create the custom editor to accommodate our needs. So let's jump right into it. Previously, we saw that there was still work to be done between our transitions to and from proning. We need to lock the character from moving until the transition is finished. To fix this, we'll need two parts. One part will be a mono behavior that will be on the player to receive the events from the animator states. The other part will be a state machine behavior that will raise these events. In other words, the character controller will listen to the component that receives the events and acts accordingly to what the event is. You could do this with the built-in animation events, but those are animation based, and they directly call your functions, making it harder to debug, whereas this solution is animator state based. We'll make a new script called com.smb event curator. Inside the script, use the Unity engine.events and create a private Unity event with a string type parameter and a Boolean variable set to false. On awake, we'll register a function to the Unity event that, for now, only shows what the event name is. So we'll create a separate function called onSMB event that takes in a string. This is important as it has to match the event, and it will display the event name if debugging is enabled. Attach this function to the event using add listener. I'll make a public property to get the Unity event from other scripts. In the inspector, add the new component to the player. Now we can see all the events pre-registered to the player. None. We'll eventually add the character controller to this list, but before that, we'll make another script called SMB event. Similar to how mono behaviors are attached to game objects, state machine behaviors are attached to state machines. Inherit from state machine behavior instead of mono behavior. Start overriding the onState enter, onState update, and onState exit functions. Then we'll define a class that will hold our information about our events. In this class, we'll have to declare several variables. We'll need a boolean to tell us if the event has already fired, a string to represent the event name, a timing to tell us when the event should be fired, which we'll define soon, and a float that will determine the frame to fire the event if the timing is set to onUpdate. Ensure this class is serialized. We'll make the SMB timing enumeration, and it will contain 4 values: onEnter, onExit, onUpdate, and onEnd. We'll also need to make several variables. Total frames will hold the number of frames of the animation clip. Current frames will track the frame progression throughout the animation. Normalized time and normalized time uncap will be the progression of the animation between the range of 0 and 1. Uncap goes beyond if the animation is looped. Motion time represents the name of the animator parameter that drives the state if it's used instead of normalized time. The list of SMB events will hold all the events that we should fire in this state. HasParam will represent if the motion time parameter exists. Event curator will be a reference to our curator component. When we enter the state, we're going to have to fill out these variables. First, we'll check if we have the parameter for motion time and assign it to hasParam. To do this, we'll make a new function called hasParameter. We'll start by checking if the parameter name is null, empty, or whitespace, and immediately return false if that's the case. If not, then we'll go through the animator's parameters and check to see if the past and motion time name matches any of them, returning true if there's a match and false if there isn't. Moving back to onEnter, we'll assign the curator by using getComponent on the game object that uses this animator. Total frames will require another function that returns the total number of frames of the state. Normalized time uncapped is taken from the state info. Normalized time will either be the value of the motion time parameter or the value returned by getNormalizedTime, and the current frame will be calculated from the total frames in our normalized time. Let's start with getTotalFrames. We'll get the array of the next animator clip infos. If there aren't any, we'll get the current animator clip infos instead. We'll simply take the first clip in the list and return the rounded quotient of the clip's length divided by its frame rate. Understand that this breaks down with blend trees, as we only take into account the first clip. With getNormalizedTime, we'll return 1 if the normalized time of the state info is greater than 1, otherwise it will just be whatever normalized time is, capping it from 0 to 1. You could also just use mathf.clamp. Now we need to define the getCurrentFrame function. It will calculate the current frame by taking the total frames and multiplying it by our normalized time, which is a percentage. So now we need to actually fire our events. First, we need to reset all of our events by iterating through each event and setting fire to false. Then, if the timing of the event is set to onEnter, then we'll set fire to true and invoke the event associated with this event name with the curator. Inside onStateUpdate, we'll do something similar. Copy the normalized time uncapped, and current frame lines from the onStateEnter. Earlier, I forgot to add a condition before the iteration in onStateEnter. If the curator is null, then there is no point in iterating through the events. We'll add this same condition to onStateUpdate and iterate through the events again. If the event has not fired, then we'll check if the timing of the event is onUpdate or onEnd. If the timing is onUpdate, we'll check to see if the current frame is greater than or equal to the onUpdate frame indicated by the event. If it's true, then we'll fire the event and invoke the event based on the event name. We'll do the same with onEnd, except we're comparing the current frame with the total frames. Inside the onStateExit, we'll iterate through the events again. If the timing is onExit and the event has not been fired yet, we'll set fire to true and invoke the event like how we did it before. Now, we want to actually implement this into our animator. Since we want the player to stop when they are doing the prone animation, inside stand2prone, we'll add the SMB event. This state is not controlled by motion time, so we don't need to set the motion time string. We also don't need to touch any of the other variables. You can make a custom editor to disable all these, but for now, we'll leave it as is. Under events, we'll add one event. We'll set the event name to proneEnd and set timing to onExit. We'll do the same for prone to crouch, prone to stand, and crouch to prone. So far, the player has a curator and the animator has the proneEnd events. However, the character controller needs to listen to these events and react accordingly. Inside the character controller, we'll create another private field that will tell us if we're in the middle of a proning transition. We also need to make the function that fires when the event is called. We'll call it onSMBEvent, which will need a matching signature of type string. All this will do is check the event name, and if it's proneEnd, then we'll set proning to false. In other words, when the event is fired, we're no longer in a proning transition. Inside the update function, if proning is true, we'll just exit early, and we'll do the same for the late update. So far, we handle setting proning to false, but we also need to set it to true at some point. Inside the request stance change, we'll set proning to be true under the conditions that move in and out of the proning state. However, even when we set this to true and stop the rest of the update function from running, the velocity of the player is still kept. Whenever proning is set to true, we need to also reset the velocity. In this case, we'll set new speed and the animator's forward parameter to 0. Copy and paste this under the crouch to prone to crouch, and prone to standing conditions. Finally, in the inspector, let's add an event to the curator. Add an event and set the object as the comp character controller component. Ensure the function is public and register the function to the event. Now, let's test this. Everything should be working as intended. Transitions going to or from proning will lock the character from moving. You should also see the event message being sent in the console. Move around and check if everything is working properly. That pretty much sums up how we implemented our crouching and proning. Since the SMB event state machine behavior is something I use pretty often, I'm going to make a custom editor to change its functionality in the inspector. The editable fields imply that you need to set them, and the default list is clunky to use as you have to increase the size to add another element. We'll disable the fields and make them unchangeable but still visible, as well as implementing a reorderable list. First, we'll make a new folder called Editor. This is a special type of folder, and it's possible to have multiple of these inside the asset folder. It separates the editor scripts on build and excludes them from the final game. We'll make a new script inside this folder called Editor SMB Event. Inside this script, Use Unity Editor and inherit from the editor class instead of the MonoBehavior class. We'll add the custom editor attribute to the class, giving it the type of SMB event. This attribute tells Unity what this editor is for. In this case, by specifying SMB event, we're telling Unity to use this custom editor if an SMB event component is being inspected. In order for us to change how the component looks inside the inspector, we'll need to override the onInspectorGUI function. If you left the base.onInspectorGUI alone, it will draw the inspector normally. We don't want that, so we'll be removing it and adding in our own code. First, we'll need to get references to the fields that we want to disable. We'll do this through serialized properties. A serialized property is a generic representation of a property that is serializable through their attribute or their accessibility level. We'll do this for total frames, current frame, normalized time uncapped, motion time, and events. Using the onEnable function, we'll assign each of these variables through the serialized object property. Serialized object is a property from the editor class that is essentially a representation of what you're editing. In this case, the serialized object represents the one instance of SMB event that you are editing. So for total frames, we'll use the findProperty function from serialized object. Note that we have to pass in the target variable name as a string to the function. That means if we ever update the variable name in the SMB event script, we'll also have to manually change them in the editor. Do this for all the other variables as well. Usually, the first thing you want to do is take the serialized object and do an update. Remember how serialized object is a representation of the object that you're editing, like a snapshot in time? Well, since it's a representation, sometimes the actual object changes but the representation doesn't. The update will avoid this, synchronizing them by making the serialized object up to date. Now, the very last thing you usually want to do is call the applyModifiedProperties function. Between these 2 points, we can change the serialized properties of the serialized object, and applyModifiedProperties will push these modifications to the original object. It's like the opposite of the update function. At this point, we haven't actually drawn anything inside onInspectorGUI, so our inspector looks empty. We'll start with using editorGUI layout.property field. It will draw this property as how Unity would normally draw it in the inspector. If you have any sort of attributes, it will apply those to the layout as well. If you want more control, editorGUI.property field is more customizable. However, we'll stick with what we have right now. We'll do this for the rest of them, except for events. We want to have it so that these fields are visible to the user, but not editable. We'll discuss 2 ways to do this. For the first way, it's simply surrounding the properties we want to disable with GUI.enabled. This will disable them in the inspector, just like how we want it. For the second way, we'll utilize a disabled scope to disable our properties. We'll be using the second way for our project. Make a using statement, and in this statement, we'll declare a new editorGUI.disabledGroupScope. For disabled group scope, we want to pass in a condition for it to be disabled. However, we want it to always be disabled, so we'll just pass in true. Move the property fields into the scope, excluding motion time, and there you'll have it. The inspector now has these fields disabled. Now, let's tackle the events. Normally, it would look like this inside the inspector. It's doable, but it's not the greatest when we have to handle multiple events. So we'll transform this into a reorderable list. An example of a reorderable list can be found in a state machine transition. The conditions can be freely added, deleted, and reordered, which is what we want for our events. We'll first add the Unity Editor internal namespace and create the reorderable list called mEventList. Inside onEnable, you'll need to change a few parts of the reorderable list to get our desired look. In this case, we'll change drawHeaderCallback, how to draw the title of the list, the drawElementCallback, how to draw the elements inside, and the elementHeightCallback, the height of each element. For each of these properties, we'll assign them different functions. The drawHeaderCallback function takes a rect. Since we're given the rect, we can use editorGUI.label field and pass in the rect and the name of the reorderable list. We'll just call it events. For the drawElementCallback, it expects several things: a rect, an index of the element in the list, and 2 booleans called isActive and isFocused. Inside this function, we'll create another serialized property called element, and before we continue, we first need to assign the events list variable within onEnable. We'll make a new reorderable list and we'll pass in several things. For serialized object, we'll pass in the editor's serialized object. For elements, we'll pass in events. As for the other booleans including draggable, display header, display add button, and display remove button, we'll set them all as true. Now back to our draw element callback function. We're going to make 3 serialized properties. The first is called element, and it's going to represent the SMB event at the specified index in the event list. The second is called event name, and we'll need to access the element's find property relative function and pass in the name of the string variable associated with the event name. The last one is called timing, and again, we'll use the find property relative and pass in the exact same name as the timing variable used in the SMB event class. Although each of these variables represent different things, element a SMB event, element name, a string, timing, and enum, they are all still just serialized properties, generic representations. In order to extract the values, we'll have to use the properties of the serialized properties. Let's demonstrate this. Create a string called element title and an integer called timing index. Timing index is initialized to the enum value index property of timing. For element title, we'll first check if an event name is present. If it's empty, then we'll just access the enum display name property of timing and specify the index using timing index. If it's present, then we'll do the same thing as before, but this time we'll include the event name inside the element title instead of the placeholder. Now let's draw this element using editor.GUI.property field. Pass in the rect, the element title, and true for including children. For the element title, we use GUI content. GUI content allows you to set labels, tooltips, or pictures to the property field. In this case, we just use a string to create a label for the field. We'll now create the element height callback function. This function expects an index and returns a float. Again, we will get the element at the specified index. In the draw element callback, we simply drew the element as how Unity would do it because we used a property field. So that means we don't have to do anything special here, and we don't have to manually calculate the height. We can use the getPropertyHeight function from editor.GUI to get the height of the element and return that value. Now to actually draw the reorderable list, we'll call the doLayoutList of the event list inside the onInspector GUI instead of the property field we had before. Now, back inside the project, it's starting to take shape, but there's an overlap between the arrow and the triple line bar. There are a couple ways to fix this. One way involves altering the draw element callback function where you offset the rect and move it along the x-axis. Another way involves a second using statement, similar to how we did the disabled group scope. Inside onInspector GUI, add a using statement with a new editor.GUI indent level scope, and we'll pass in 1. This means within the scope, the level of indentation is increased by 1. Once the scope is left, indentation returns back to normal. The last thing we need to do is reference a script in our assets. When we click on scripts in the inspector, we get pinged to the asset inside our project. To do this for SMB event, we'll return to the disabled group scope. Here, we'll add an object field. The first thing we pass in is a string for our label. The second thing we'll pass in is the object using monoscript.fromScriptable object. For the fromScriptable object, the scriptable object that needs to be passed in will be our target. Target is another property that is exposed just like the serialized object. We'll have to cast this to our SMB event type. The next thing is our object type, which is just going to be a type of SMB event. Lastly, set the scene object to false. This isn't really necessary as you won't be able to drag and drop objects into this field anyways. Add a space using editor.GUI.space, and back in Unity, we can now see the script in our inspector. When you click on it, it should ping the script and you can quickly access it without having to navigate the project. And there you have it, a custom editor for your state machine behavior. We successfully implemented proning and crouching to our character controller system and fixed the transitions to and from proning. With how everything is set up, implementation of other character controls should be much faster and more intuitive. Try using this event system to implement your own features. We may expand on this in the future, but for now, this character controller system should be sufficient for general use. Thanks for listening, and I'll see you next time.